What if the universe wasn't so big? Or at least, what if all that distance didn't matter so much? Imagine hopping over to the nearest star, not in tens of thousands of years, but in just a few weeks. The idea of traveling faster than light has always felt like pure science fiction, but the real science behind it, that's where things get really weird. The universe is vast on a scale that's hard to wrap your head around. Our closest stellar neighbor, Proxima Centauri, is over 4 light-years away. With our current technology, a trip like that would take tens of thousands of years. The core of the problem is a cosmic speed limit, courtesy of one of the most famous names in science, Albert Einstein. According to his theory of special relativity, nothing with mass can travel at the speed of light. As you get closer to it, your mass increases, and hitting that final light speed barrier would require an infinite amount of energy. This isn't just a tough engineering problem, it's a fundamental rule of our reality. It seems unbreakable. But what if the goal isn't to break the rule, but to find a clever way around it? If you've ever watched Star Trek or Star Wars, you've already seen the proposed solution, the warp drive or hyperspace. These ideas might seem like fantasy, but they're inspired by a tantalizing scientific possibility. What if, instead of trying to move through space faster than light, you could move space itself? This is where the theory gets bizarre. In 1994, physicist Miguel Alcubierre proposed a concept that sounded like it was pulled straight from a sci-fi script. The Alcubierre drive doesn't actually propel a ship through space. Instead, it would generate a warp bubble around the spacecraft. This bubble would work by contracting space-time in front of it and expanding space-time behind it. The ship would just ride this wave of space-time, staying perfectly still inside the bubble. To someone watching from far away, the bubble and the ship would appear to be moving faster than light, all without ever locally breaking Einstein's laws. But there's a monumental catch. The original model for the Alcubierre drive requires a form of matter with truly strange properties to create this distortion. Something called exotic matter with negative energy density. The only problem? This kind of matter has never been observed, and we're not even sure it can exist. The warp drive isn't our only hypothetical shortcut. General relativity also allows for another mind-bending possibility: wormholes. Think of space-time as a giant sheet of paper. To get from one point to another, you could travel the long way across the surface. Or you could just fold the paper and punch a tunnel straight through. That tunnel is a wormhole, a potential shortcut across the cosmos. These cosmic tunnels are mathematically possible, but just like warp drives, they have a big stability problem. Without something to prop it open, a wormhole would collapse instantly. And the substance needed to stabilize it? You guessed it, exotic matter. While some newer theories suggest that microscopic wormholes might be possible without it, any tunnel big enough for a person to travel through remains firmly in the realm of speculation. For decades, the need for exotic matter made faster than light. Travel seemed like an impossible dream. But recently, the conversation has started to change. Theoretical work is beginning to chip away at these barriers. In 2024, a paper published in the journal Classical and Quantum Gravity proposed a new warp drive model. The exciting part is that this new concept describes how a warp bubble could be created using a sophisticated mix of gravitational techniques that work within the known laws of physics, potentially eliminating the need for negative energy. Now, to be clear, this model doesn't achieve faster than light speeds yet, but it does suggest that warp effects might be possible using regular matter and energy, a huge conceptual step forward. It's a finding that could begin to move the idea of a warp drive from pure fiction into a subject for actual engineering. These are the very first steps, turning an impossible idea into a monumental, but maybe not impossible, challenge. If you love exploring these mind-bending possibilities of science, make sure to subscribe and hit that notification bell so you don't miss our next journey into the unknown. And we have to ask, if you had a faster-than-light ship, where would you go first? Let us know in the comments.